Assalamualaikum and salam sejahtera. I am Nazif bin Saman, the first presenter for Group 1 from the Edit 3P. The purpose of my presentation today is to give you some information on Chapter 3, Combustions and Fuel Characteristic. In today's presentation, I will share about combustion process terms such as normal and abnormal combustion, ignition, pre-ignition, ignition delay, and advance and retard. So let us move on to introduction for this Chapter 3. In this topic, cover all of the understanding on combustion process, spark ignition engine, and compression ignition engine. This topic also covers the knocking phenomenon and fuel characteristic. Next is objective. At the end of this topic, you will be able to describe the combustion process in spark ignition and compression ignition through engine pressure versus crank angle diagram. Define the term of knocking, describe the knocking phenomenon in spark ignition engine, and define the normal and abnormal combustion engine. Now let us take a look at the first combustion process term, normal combustion. A combustion process which is initiated solely by time spark and in which the flame propagates regularly to the walls mixture with normal velocity. Next is abnormal combustion. A combustion process in which a flame front may be started by hot combustion chamber surface either prior to or spark ignition. Abnormal combustion also causes spark knock and surface ignition. Diagram 1 is the example of normal and abnormal combustion. Now let us move on to the term of ignition. The ignition system is designed to ignite the air and fuel that have been mixed in the fuel system. Today, ignition systems are almost totally computer controlled for improved combustion. Pre-ignition. This process is where spark is heated up before the ignition begins. This can cause rough running and also can do damage to the engine. The causes of this pre-ignition usually include glowing carbon deposits on a hot exhaust, auto ignition of engine oil droplets, and sharp edge on valves that were reground improperly. Ignition delay is defined as the time lag between the start of the combustion when air-fuel mixture is ignited. Delay period is the commencement of injection and it is indicated by the dots on the compression line 15 dot before the dead center. The period 1 is the delay period during which ignition is being initiated, but without any measurable departure of the pressure from the air compression curve, which is continued as a broken line in the diagram as it will be recorded if there were no injection and combustion. Now let us move to combustion process term of advance and retard. Advance refer to the number of degree before top dead center PTDC that the spark will ignite the air-fuel mixture in the combustion chamber during the compression stroke. Retard defined as changing the timing so that the fuel ignition happens later than the manufacturer's specified time. For example, if the timing specified by the manufacturer was set at 12 degrees PTDC initially and adjust to 11 degrees PTDC, it will be referred as retard. I think I've covered all of the combustion process term. Now let us move on to the second presenter. Bye.
So, I want to present about the pressure versus crankshaft position diagram. As you can see at my slide, there is a intake and exhaust. At the intake, when the gas reduces, intake valve is open and exhaust valve is closed. After that, intake valve is closed when it is a compression. At the exhaust, intake valve is exhaust valve is open when a expansion and intake valve is open. The second diagram is a crank position and angle. I want to explain the process based on the pressure versus crankshaft position diagram. When the 0 degree until 118 degree, the intake valve open, the intake valve mechanism occurred and the piston shift from the top dead center to the bottom dead center. There is a combination of fuel and O2 entering the cylinder. The exhaust valve closed during the stroke and the pressure remained contained. At the 180 degree until 6 until 360 degree, the intake valve is closed. Piston rise from the bottom dead center to the top dead center. The mixture of fuel and O2 is compressed and the pressure is rising. Spark plug will turn on the before TDC. TDC means is ignition delay. The third is a 360 degree until 540 degree. Close intake valve and close exhaust valve during power stroke. Piston travel down from the top dead center to the bottom dead center. The exhaust at the end of this process. Open valve. The pressure is going to decrease. The 540 degree until 720 degree. Piston goes up from the bottom dead center to the top dead center. The result of the combustion is expressed from the cylinder. During this process, the intake valve is open and continues for the next cycle. The third is the effect of engine speed on ignition timing. Ignition timing in a spark ignition internal combustion engine is the method of setting the engine relative to the position of the piston and the angular velocity of the crankshaft that will occur in the combustion chamber at the end of the compression stroke. The timing event refers to the number of degrees in front of the upper dead center that the air-fuel mixture can ignite the combustion chamber during the compression stroke. Ignition and mixture before the piston reaches TDC will cause the mixture to burn completely soon after the piston reaches TDC. The third is a delay timing can be described as adjusting the timing so that fuel injection occurs later than the specified time of the manufacturer. For the example, if the timing specified by the manufacturer was initially set at 12 degree, BTDC and change to 11 degree, it will be referred to as delay. The last is the effect of advanced and related ignition timing on combustion process. If the ignition spark happens at a position that is too advanced relative to the position of the piston, the rapidly expanding air-fuel mixture will actually force the piston upward, causing knocking and potential engine damage. If the spark happens too slow compared to the position of the piston, the maximum pressure of the cylinder may occur after the piston has already moved too far down the cylinder. This results in power loss, overheating, high emission, and unburned fuel.
I will present the last part of our presentation, which is knocking or detonation system in spark ignition. This process that happens within the combustion chamber, it sounds like a small ticking or rattling noise within the engine. In long term, the piston and ring can be damaged as well as the spark plug and the valve. So that surface ignition. Surface ignition is ignition of the fuel air charged by any hot surface other than the spark discharge prior to the arrival of the normal flame front. The next is knocking phenomenon in spark ignition. This occurs when combustion of some of the air or fuel mixture in the cylinder does not result from propagation of the flame front ignited by the spark plug, but one or more pockets of air or fuel mixture explode outside the envelope of the normal combustion front. Knock occur when the peak of the combustion process no longer occur at the optimum moment for the four-stroke cycle. So the next is we go to the factor that contribute knocking. Increased compression, high temperature, lean fuel or air mixture, advanced ignition timing, and lower octane fuel. So now we go to the effect of knocking to the engine. A drop in engine performance, pollution of gases from the combustion is not complete, and high consumption of fuel. Method to control or reduce knocking. Increase the ignition combustion engine, reduce the heat the final combustion, reduce the combustion temperature and increase the margin above detonation, and use high quality of fuel. The use of fuel with high octane rating, which is increase the combustion temperature of the fuel and reduce the proclivity of donate. So that's all from our group. Thank you.